In this lecture, we talk about linked lists, which is a linear data structure, which is different from an array. In case of array, we have seen that all the elements are stored in a contiguous memory locations, and whenever an array is declared, memory is already allocated for the according to the size of the array. So there's one advantage with the array is that we can directly access any element of the array, and the disadvantage is that memory is unnecessarily occupied or reserved for arrays. So if you are going to use more number of arrays, more memory is being occupied. Now, in case of linked list, this is not the case. We can dynamically adjust the memory according to the requirements. Basically, a linked list can be thought of a collection of memory blocks, where data is stored in the memory block. Apart from that, we'll also store the link to the next memory block. So the starting memory address of the next memory block can be stored here, so that data is available here, and from this where to go is also stored here. So link is established to the next memory location. This is how linked lists operate. Now when it comes to the implementation in C, there is a beautiful structure is there. Concept is the structure. We can use structure concept in C programming language to create a node, which facilitates us to store the data as well as a pointer. If I store the data in the form of int or real or character, whatever it is there, we can store it, and we can have a struct node star next, which is a self-referencing pointer pointing to the next memory block. So this memory address can be stored here. By using this concept, of course, we can type def this structure definition. We can define type def struct node. Into data is there, struct node star next node. So once we create this type def, whenever we call node, it creates we can create a node, right? So node star create node into data. So whenever you want to insert data into that into node, by creating this, we can call this function, which indicates node star new node is equal to malloc size of node. So if we know the size of the node that is to be created, we can allocate the memory for that new node, and this returns the starting memory address of that. And data of the new node is inserted into the data, and initially we set next of new node as null. So basically when we are creating a new node, the next node is not available, so we store null in the address part and return new node. So this returns the starting memory address of the node that is being created. So if we type def like this, whenever we create a node, it returns the starting memory address of the node that is being created, with the data is inserted and linked to the next node as null. So like this, we can keep on creating new nodes. This is with respect to C programming language. Conceptually, we can thought of node as consisting of two parts. One is data part and one is a link part, which is variable next is used here. We can use next or link or whatever variable that is pointing to the next memory block. So if you look at this diagram, head 1 is consisting of the memory address 1024. So this is the starting memory address of the first node of the linked list. This consists of the variable next, which points to the next node. Again, another memory block is there, data and next is there. Since in the next part, if we store the memory address of the next block, then we can establish a link from between the two nodes. Like this, we can keep on creating the new nodes and establish the links. Here is an example. Node 2, head 2 is taken here with the 2042 as the memory address. So 2042 is the starting memory address of the first node that is created, and the data present in the first node is 2, 5 is the data, and 2030 is the link, which is the starting memory address of the next node. So the memory address is stored here in the next variable. Once we access the first node, we can access the value of the 2030. Thereby, we can establish a link to the next node. We can reach the next node. Again, next node has the data 3, 4. Along with that, address to the next node, that is 2034. Like this, we can keep on augment node after the node as per the requirement. When it comes to the last node, 4, 0 is the data and null is there in the next location, which is indicating no more node is present after this. Okay, so here the linked list consists of 5 nodes. Now, how do we access this linked list? With head pointer. Head is a variable used to indicate the starting memory address of the first node. So it is enough if you know the starting memory address of the first node to access the entire linked list. From that, you can keep on accessing through the next variable each of the nodes and until you reach the last node. This is how we can visualize a linked list. We can describe the abstract data type of linked list, or list for that matter. What are the operations that we can perform on this? Get is one function which returns the element from the list at any given position. Suppose if I want to get a third node, data at third node, we can access that through this function, get node. Traverse right from the beginning, head node to the tail node, we can keep on traversing and keep on printing or process the data, traversing. Insert, if I want to insert a new node, again that node insertion can be done in 3 locations, either at the beginning or at the end or in the middle. Node can be inserted into the linked list and we can adjust the list. Similarly, delete also can be done at 3 locations, either at the beginning or at the end or in the middle. Node can also be deleted and adjust the remaining linked list. Replace the element at any position by another element. Size, which indicates the size of the linked list, and is empty. Under what conditions we say that the linked list is empty? Get is a functionality which returns an element from the list at a given position. Suppose if I want to know the data present at the kth link or kth node rather, then I need to start at the head, because any linked list can be given as an input only through the head, which is a pointer pointing to the first node. So from that node until kth node we have to traverse. There is no mechanism directly to landing to kth node, because we need to start at the head and we need to reach the kth node and then read the data. This is one of the drawbacks of the linked list also. So we start with the head and initiated this head to temp, count as 0, and we are maintaining a counter in the while count is less than k. We go to the next node via the link for the next. So temp is updated as next of temp. So whatever current node is there in the next variable, it is holding the memory address of the next node. So that is why I am updating temp as next of temp, and count is incremented. So this continues until I reach the kth node. Once I reach the kth node, the while condition fails, and by the time the temp consists of the memory address of the kth node. Now, whatever data is present in the kth node, we print that. And when it comes to the traversing, the second one is traversing. Similar to that, instead of k, we'll reach until the end. So starting from the head node, we keep on traversing in the similar fashion. Head is taken to temp, and while temp not equal to null, we keep on printing the data on every node, and until we reach temp is updated as next of temp. Once we reach temp is equal to null, that's an indication that we have reached the last node. This is how we'll print all the data of all the nodes. Insert operations. Insertion can be done in three ways. Insertion at the beginning, insertion at the end, insertion after the kth location. Suppose if we consider the linked list here, insertion at the beginning, whatever current head is there, that has to be updated as a new node shall be created, and a new node shall be taken as the head. and the link has to be given from the new node to the existing starting node. So this action can be done. Here we are initiating new node is equal to create node, which creates a new node and returns the memory address of the new node created into the variable new node. Then next of new node shall be taken as the current head. Whatever current head is there, that has to be the memory address of the newly new created node, and the memory address of the new node shall become the head. So head is equal to new node. So with these three actions, we can create a new node and append to the at the beginning of the given linked list. This is how depicted here. E is added to the existing linked list, and 2042 is the address of the previous head that is updated here as a link to the node consisting of E, and whatever memory address of the new node is taken as the head node. Similarly, if you want to insert at the end, so whatever node that we are going to insert, for that we need to traverse through the given linked list until we reach the last node. So we initiate the traversal with the head as temp, and while temp not equal to null, we keep on traversing through the nodes. Here again, we are keeping a previous as a variable which is keeping track of the previous node at any point of time. So once temp reaches null, that means once the temp is a variable which is reaching the null, means it is reaching the last node and it is reading the memory address that is there in the last node. So null is there, and by the time previous shall consist of the address of the last node. So D, whatever is there, D is the last node. The starting memory address of the node consisting of D shall be there in the temp, sorry, previous, and null is pointing to the temp. So if at this stage we want to create a new node, and new node is created as new node, and next of previous is taken as new node, because in the previous the starting memory address of the node consisting of D is there. For that we are appending a new node here. So new node is given to next of previous, and next of new node shall be taken as null. So once new node is created, that should be the new end node for the given linked list. So E is appended to D and null is taken as the next of E. This is how we'll insert at the end. Now if you want to insert after kth location, so similarly we'll start with the head node. We keep on traverse until kth node. Once I reach kth node, so previous shall consist of the memory address of the kth node. Then create new node is created, and next of previous is a new node, and next of new node is shall be taken as temp, because temp is holding the memory address of the next node. So E is appended in between B and C in this fashion. Now when it comes to the deletion of the node, again that can be performed at the beginning node, or head node can be deleted, or the last node can be deleted, or the kth node can be deleted. If you want to delete the head node, so once you want to delete it, whatever with the next node is there, that should become the head, and this node has to be scrapped. So for that, the given input is head again, pointing to the first node's pointer memory address. Then temp is equal to head, we have taken it into temp. Then head is updated as next of temp, because in the head node whatever is next is there, that is pointing to the second node in the given linked list. So head is updated as next of temp, and then the first node has to be deleted. Delete temp, the first node is deleted. This is deletion from the beginning or head node. Now if you want to delete the last node, again we need to traverse through the given linked list until we reach the last node, but in this process we need to remember the previous node, because that's the node we have to stop. For that, again, just if you look at the logic that we follow there for this, is temp is equal to head. Again we are traversing through the given linked list while condition is used. Next of temp not equal to null is the condition. Previous is equal to temp, that is we are remembering the previous node, and temp is equal to next of temp, it is updated. Once we reach temp is equal to null, that means we reach the last node. and the previous consists of the address of the last node. And what is that we're doing? That last node shall contain next pointing to the null, because that should be the last node, and we need to delete the last one. So delete temp, whatever is there, and next of previous is null. We made next of previous as null. So by this, the last node is deleted, and the previous node of the last node, penultimate node, becomes next of that becomes null. Now, if you want to delete the kth node, this is a little bit involved, because once you want to delete the kth node, whatever node before that should have the link to the next of this kth node. That has to be established, re-established. That we need to take care. But before that, we need to traverse starting from the head to the kth node, identify the kth node, identify the previous node, and identify the next node, and establish a link between them. That is the action that we need to do. So temp is equal to head again, count is equal to 0 initiated, while count less than k, previous is equal to temp, temp is equal to next of temp, and count is equal to count plus 1. This runs in the while loop until we reach the kth node. Once we reach the kth node, previous consists of the address of the previous node. So, and temp consists of the next node of kth node. So, whatever is there in the next of temp is the memory address of the k plus 1th node. So that we are placing in the previous, which is a k minus 1th node. So next of previous is equal to next of temp. That is how we are updating here and deleting the current kth node as temp.